Hello everyone, welcome to my channel Chemical Engineering Knowledge. In the previous lecture we have discussed about the surface renewal theory of mass transfer. In this lecture we will discuss another theory which is called the boundary layer theory. The boundary layer theory boundary the boundary layer theory. The boundary layer theory is very important mass transfer theory. It is very important in the fluid flow. It is important in the heat transfer, and it is very important in also in the mass transfer. So it is important in the momentum transport, in the energy transport, and in the mass transport. So it is very important theory in the transport phenomena. Transport important theory of the transport phenomena are in the transport phenomena we discuss three phenomena, which is one is the momentum transport, which is fluid flow, velocity transport. Another phenomena is the energy transport. The third phenomena is the mass transport. So the boundary layer theory is very important in the fluid flow, in the heat and mass transfer. So in our daily life, fluid flow around substances, or like flow of air around the aeroplane wing. Similarly, flow of fluid around the cylindrical object. Similarly, flowing of fluid along pipe. Similarly, flowing of fluid surrounding the cylindrical object. So, in our daily life, fluid are flowing on substances, or fluid are flowing inside a substances. Inside in a substances, like fluid flow in channel, fluid flow in pipes. Similarly, fluid are also flowing in channel, open channel. It can be flow in inside a pipe, it can be flow in channel, it can be flow in river. So fluid flow are very important in our daily life. Similarly, air is also flowing in duct or pipe or some other material. So flow similarly air can also flow along a plate surface. The liquid can also flow on a plate surface. So suppose fluid can flow on cylinder, fluid can flow on spherical object, and can be flow on plate surfaces. So for simplicity, suppose we consider a simple example, which is a plate surface. This is a plate surface, plate surface. It means that it is a white plate. This is a plate surface. Let's consider it is a plate surface. This is a plate surface. It is a plate which is a white plate. So this is a plate. This is a plate surface. This one. So suppose fluid is suppose there is some water. Suppose a water is coming to the surface of the suppose water is coming from some other channel, or suppose water is coming from some other places, and it enter to the plate. At this position the velocity of water is called free stream velocity, which is called v infinity. This is the maximum velocity of water. Water is coming from some other places. The velocity it enter to the plate at this position. At this position, the velocity of water is constant, which is v infinity. Now as the water come to the surface, the water will some of the water will attach to the surface. It will stick to the surface. This is the surface of the plate. Surface of plate. So when water come to the surface, some of the water molecule will adhere to the surface of the plate, and its velocity will be decreases to 0. The water molecule will attach or adhere to the surface of the plate. It will move with the moment of this plate. So the plate is stationary. So the water molecule which come to the surface of the plate will adhere to this surface. It will move with the velocity of this plate surface, and we all know that this plate surface is stationary. So the water molecule which is attached to this surface will be stationary, and this case is called the no slip condition. It is called the no slip condition. So at this position, the water molecule will attach to the adhere to the surface, and the water layer will be move with the moment of plate. It means that the water molecule which form layer with the surface of the plate will be stationary, and this stationary phenomena is called no slip condition in the fluid flow, in mass transfer, and in chemical and in other in mechanical engineering. So the no slip condition, at this position the velocity of water molecule is 0. So velocity is 0, and it is called no slip condition. No slip condition. Now the water molecule, this is the layer of water molecule. Similarly, another water molecule will come. It will form layer above the below layer, but in this case the speed of the molecule in the upper layer is quite fast from the speed of molecule as compared to the speed of molecule in this below layer. So in this layer, this is the second layer. Suppose this is the second layer, this is the first layer. So the speed of molecule of water in the second layer is fast as compared to the speed of water molecule in the layer number 1. So in this case the water molecule which are present in the layer number 1 will tend to stop the water molecule which are present in the layer number 2. So in this case the water molecule which are present in the layer number 2 will be slightly their moment will be slightly decreased, their velocity will be slightly decreased. So but their velocity will be increased from the velocity of water molecule which are present in the layer number 1. Now another water layer will come, and it will form layer on the second layer. It will form water molecule will form layer of water on the second layer, and this is called the layer number 3rd. So the third layer, now the velocity of water molecule in the layer number 3 will be higher as compared to the velocity of water molecule which are present in the layer number 2. So in this case the velocity of water molecule in layer number 3 will be higher from velocity of water molecule which are present in layer number 1, and the velocity of water molecule which are present in layer number 2 will be higher from velocity of water molecule which are present in layer number 1. So in this case there will be If we see to the layer number 2, then there will be two forces on water molecule which are present in layer number 2 uh, the below molecule. The below below molecules will tend to stop the motion of the water molecule which are present in layer number 2, but the water molecule which are present in layer number 3 will tend to pull pull the water molecule which are present in the layer number 2. So the water molecule which are present in layer number 1 will try to stop the movement of water molecule which are present in layer number 2, but water molecule of layer number 3 will try to pull the water molecule of layer number 2. So in this case, the speed of water molecule which are present in layer number 2 will increase because of the force which these molecules exert on the below water molecule. So these molecules exert force on the below molecule. As a result, the molecule present in the second layer will be move in the rightward direction. Similarly, a fourth layer of water will be formed, and in the fourth layer the water molecule will push the water molecule which are present in the will pull the water molecule which are present in layer number 3, and so on and so on. The above molecule, if we consider this is layer 1, layer 2, layer 3, layer 4. If we consider layer number 4, then there will be two forces. One force will act on the water molecule which are present in layer number 4 from the below side, from layer number 3, while the other force will be exerted by water molecule which are present in the layer number 5. So the layer number 3 will try to stop the movement of water molecule which are present in layer number 4. This is layer number 4. This is layer number 4. This is layer number 5. So if we consider layer number 4, this is layer number 3. If we consider layer number 4, then this layer number 3 will try to stop the movement of water molecule which are present in this layer, but the water molecule of this layer will try to pull the water molecule in the forward direction. So as a result, the water molecule will try to move in the forward direction. So in this case, the velocity boundary layer will be formed on the surface of a plate. So the velocity boundary layer is formed on the surface of a plate. So this is the so in this case, the velocity boundary layer was formed on the plate. So again, this is a plate surface. This is a plate surface. This is a plate surface. The water, this is the water which come from some source. The velocity of water at this place is v infinity. This is the free stream velocity. Free stream velocity of water. Free stream velocity of water. As the water molecule come to the surface, it will stop. The first molecule will stop. It will form layer on the surface of stationary layer on the surface of the plate due to no slip condition. Similarly, the second layer of water molecule will move slightly in the forward direction. The third layer will move in the forward direction due to the force which act the fourth layer act on the third layer. Similarly, the third layer move in the forward direction due to the force which this layer exert on this layer. So similarly, the water molecule will move which are present in the layer number 5 will move in the with the higher velocity. So the velocity of water molecule in this layer will be highest. In this layer it will be higher but lower from this layer. Similarly, the velocity of this layer will be higher but from this layer but it will be low from velocity of water molecule which are present in this layer. Similarly, the velocity of water molecule which are present in this layer will be higher from the velocity of water molecule which are present in this below layer, but it will be less than from velocity of water molecule which are present in this layer number 3. So in this case a velocity change occur on the surface of the plate. It means that velocity here the velocity was 0, and if we slightly move in the upward direction on the plate, suppose this is a plate, this is suppose x-axis, suppose this is the y-axis, suppose this is the z-axis into the plane. So this is the y-axis, this is the z-axis. So the water molecule which come to the surface has 0 velocity, which is called no slip condition. The velocity, if we move in upward direction in the y direction, in this direction, the velocity of water slightly increase. If we further move in upward direction, the velocity will further increase. If we further move upward, velocity further increase. If we further move in upward direction, then velocity further increase. If we further move in upward direction, then the velocity will further increase. So it means that the velocity changes in the y direction. The velocity changes in the y direction. This is the y direction. This is the y direction. Upward, in the upward direction is the y direction. So the velocity changes in the y direction. So velocity is a function of y direction. So in this case the velocity is changes in the y direction. Now why the molecule in this position is low velocity? The molecule in this place is slightly higher velocity, in this place is further higher velocity, in this place is further higher. Molecule in this place is highest velocity. Why? It is due to the force, it is due to the shear forces, and the viscosity of water. So this solid surface exert force on the water layer in this direction. Due to this shear forces, the velocity of water on the surface of a plate is 0, and as we move higher in the plate, the velocity is increases, and the shear stresses decreases. The viscosity decreases, and the velocity increases as we move in the upward direction. So as we move in the upward direction, the shear forces, the boundary condition or the boundary influence decreases. The viscosity of the flow of the liquid will be decreases, and the velocity of the water will be increases. As the velocity of water increases, its viscosity decreases, and the shear force which act on the water, and the shear forces also decreases as we move in the upward direction. So there is some place on the plate where up to which the boundary effect is prominent. On the surface of a plate, there is some distance up to which the effect of this wall is high. So this is a plate, the wall of a plate surface. This is the wall, the uh, plate surface. This is the plate surface, plate surface, and there is some distance in the upward direction up to which the effect of this wall is cannot be neglected. So up to certain points, up to certain height on the plate surface, there is the effect of the wall, the effect of the wall, uh, and the height up to which the effect of wall is cannot be neglected is called the boundary layer. So suppose this is the further higher velocity, this is the higher velocity up to this is called the free stream velocity. Now this velocity is same, the velocity of this layer and this layer are same. Further, the velocity of every layer above above this point the velocity of every layer above this layer is same, and this velocity is equal to the velocity of free stream. So above this point the velocity of the liquid layer is equal to the velocity of free stream. So the distance up to which the effect of boundary is can be the effect of boundary is filled is called the boundary layer. So up to this position the velocity was changes, and above this position the velocity is not changing. So the distance, this is the y direction and this is the distance or the y direction. So the distance up to which the effect of this this wall is filled, the distance up to which the effect of wall the distance up to which the effect of plate or the distance up to which the effect of this wall is filled is called the boundary layer, so this distance, this is the boundary layer, this is called the boundary layer, and above the boundary layer it is called the free stream velocity, free or irrotational velocity or irrotational motion, or this is the boundary layer, and this is the free stream velocity, free stream velocity, and the flow in this layer is called irrotational flow, irrotational flow. The viscosity in this layer is low, low. The viscosity is present in this irrotational flow, but it is small as compared to the viscosity in this boundary layer. So the viscosity in this layer is higher, it is viscous region, viscous region. The viscosity in this layer is high, the boundary layer is high, it is viscous region. The flow in this layer is usually the laminar flow. Viscous flow is usually laminar flow in fluid mechanics. So this is the boundary layer theory, the concept behind the boundary layer theory. So in the boundary layer there are two regions are formed. One is the region where the effect of boundary can be felt, and one is the region above which the effect of boundary is not felt, and the region above which the effect of boundary is not felt is called the free stream velocity or irrotational flow. So this is about the boundary layer flow. So again this is a plate surface, this is the velocity here is no slip condition, velocity is small, above velocity is higher, further velocity further increase, it is further increase, here the velocity is same. So up to this up, up to this position this position, the effect of this boundary, effect of this wall, effect of this wall is built up to this position, and this, suppose this is the y direction. So this is the y direction, this is the y direction, this is the x direction, and this is the y direction. So up to this position, the effect of boundary is built, and this layer is called the velocity boundary layer, and this is the irrotational flow, and this is it is the flow here is equal to the free stream velocity. So velocity here is in this position, the velocity is of water is v infinity, just like the velocity in this position, this is v infinity. So the velocity changes with the y direction. Similarly, the velocity of water is changes also in the x direction. The velocity of water, suppose this is suppose if we consider some distance, suppose this is a point, this is a point. Suppose if we consider a line, imaginary line, which is suppose consider imaginary line which is perpendicular to the plate. So the velocity at this position, the water molecule, the velocity of water molecule at this position is 0. The velocity of water molecule at this position is slightly increased. The velocity of water molecule at this position is further increased. The velocity of water molecule at this position is further increased. So along apex line, along apex line, the velocity of water increases along an imaginary line, which is apex line at one x position. Suppose this is x is equal to x1. The velocity of water at this position is 0. Velocity of water at this position will be increase. At this position it will further increase. At this position it will further increase. At this position it will further increase. Similarly, if we consider this point, suppose take another imaginary line which is perpendicular to the x-axis. This is x-axis, and this is the y-axis. So take imaginary line along the y-axis. So this is, suppose this is x is equal to x2. So at this position the velocity will be, suppose at this position the velocity is 0. At this position the velocity will be increase. At this position the velocity will further increase. At this position the velocity will further increase. Above it will be up to this point. Suppose up to this point the boundary effect is built. So this is the boundary layer. Suppose up to this position the boundary effect was built. This is the boundary layer. So up to this is the boundary layer, this circle. Similarly, this is the boundary layer. This is the irrotational flow. This is irrotational flow. So the velocity of water at this position, which was 0, at this position it was 0, but the velocity, suppose if the velocity at this point was 2 meter per second, but the velocity at this position was, suppose it was 1.5 meter per second. Similarly, if we compare the velocity at this position, it will be higher. The velocity at this position will be small. Suppose the velocity at this position is 5 meter per second, but if we compare the velocity at this position, it will be 3 meter per second. Similarly, if we compare the velocity at this position, suppose at this position, suppose if we compare check the velocity at this position, and the velocity come out to be 3 meter per second, and now if we compare the velocity at this position, then it will be decrease from 3 meter per second, say it will be 1.8 meter per second for example. So the velocity is the main point is that the velocity is a function of x direction also. So the velocity at this position will be different, and the velocity of water at this position will be different. At this circular ring will be different. Similarly, the velocity changes in the x, as the velocity changes in the x direction. Similarly, the velocity was also changes in the y direction, as we have already seen that the velocity at the surface was 0, and as we increase in the height, the velocity was increased. The velocity was increases as we go higher. So the velocity as we go higher, the velocity also increases. as we have already seen. Similarly, as we go from left to right, the velocity also decreases or mean velocity changes. It can be increased or decreased. So the velocity is a function of x. Mean if we go in this direction, velocity changes. Similarly, if you go in this direction, the velocity also changes. So the velocity is a function of x and y position. So this is all about the boundary layer theory. The boundary layer is not just to the plate. The boundary layer can be formed on aeroplane plane. It can be formed on irregular surfaces, which is quite complicated phenomena. So the boundary layer can also be formed on spherical surface. Suppose a sphere, the air, suppose air passing through this surface, so a boundary layer will be formed on the surface. Suppose a sphere, the boundary layer will also form on the surface of the cylinder. Suppose this is a cylinder, flow is flowing inside the cylinder, but flow is also flowing outside the cylinder. So the velocity at this position will be zero, no slip condition. The velocity above will be increased, it will be further increase, it will further increase. So the velocity will be, boundary layer will be formed. So up to this, the boundary effect is built, which is the boundary layer above. There is irrotational flow. Similarly, the velocity at this position is zero, increases. So the velocity boundary layer is also formed in at this position. So if the flow is flowing on outside of cylinder, then boundary layer will also form. If flow is passing on the outside surface of a sphere, then the boundary layer will also form. So it is all about, this is all about the boundary layer which is formed on a plate surfaces. So the main concept here is when a fluid is flowing on a plate surfaces, so then there will be two region will formed. In the first region, the effect of boundary is higher, which is called the boundary layer, and in the other region, the effect of boundary is small, which is the free stream velocity or rotational region. In the boundary layer, the viscous effect is higher. The flow is usually laminar, and the Newton law of viscosity is obey in the boundary layer, can be obey in the boundary layer, and in the irrotational flow, the turbulent equation, the turbulent correlation is usually used. So this is all about velocity boundary layer. Uh, in the previous theory, we have discussed the surface removal. The previous theory was about surface removal. This theory is about the boundary layer. So suppose some more thing about the boundary layer. This is the plate. This was fluid which was flowing on the surface. This is the free stream velocity. So this region is called the boundary layer. This is the irrotational region. So as we up to this height, this is the boundary layer thickness. This is the boundary layer thickness. So as we go in the x direction, then the velocity the boundary layer thickness also changes. So the boundary layer is also a function of x. So in the coming lecture, we will discuss the correlation about the boundary layer, the Sherwood number, and how the mass transfer coefficient is related to the diffusivity according to the boundary layer theory. So thanks. If you are new to the channel, please like and subscribe.